Other than Klebsiella, it also had Serratia marcescens in it. Serratia, what is this? Some red color is gonna come out. So before I go to that, please remember Serratia will always enter into your surgical side things like IV cannulas, surgical instruments, antiseptic solutions. तो जितने भी surgical instruments हैं या फिर antiseptic solutions हैं या contaminated IV lines हैं, into that Serratia is gonna go. What all does it cause? Wherever it will go na, as I told you, a red color will come. So if it causes pneumonia, what is it gonna cause? Pseudohemoptysis. Pseudohemoptysis means the person will have cough, and along with that the person will have sputum, and the sputum will have a red color. So as soon as someone starts spitting out red color sputum, you say, "Arey, he's having hemoptysis." But is this person having bleeding? No. This person is having Serratia infection. So that red color is nothing but the pigment of Serratia. It is a false hemoptysis. Similarly, he can have eye involvement. That is going to be contact lens keratitis. Again, red pink color aana chahiye. That is known as a pink hypopyon. So there's a pink hypopyon again because of Serratia pink color. Similarly, meningitis, they can have cardiac involvement, septicemia, all other organs are possible. But having pseudohemoptysis and pink hypopyon, pink, red color is important, and that is how the slide is going to be. What color pigment does it have? It has a red color pigment at room temperature. What did I say? Now you can write Serratia easily for all of you. What is Serratia, guys? S is going to be, it is going to cause many of the surgical site contaminations. That could include IV cannulas, solutions, surgical instruments. Then it is going to produce a red color pigment which is going to be at room temperature. And where do you see the red color pigment? Only where the organism is. Has the entire slide become red? No. So what kind of a pigment is it? It is a non-diffusible pigment known as protogeosin. So jo pseudohemoptysis karayega, that is going to be a protogeosin. So remember, this red color pigment is referred to as protogeosin, and it is responsible for all pink color things. That is pseudohemoptysis, pink hypopyon. These are the things that you should be knowing. Quick revision: Serratia for surgical site, red color pigment called protogeosin, which is going to be produced at room temperature. It is non-diffusible. Let me remind you, you did a pigment for Staphylococcus aureus. What color was it? Staphylococcus aureus, AU for golden. That was a golden color pigment. Now you're doing a pigment for Serratia. What color is it? RR. It is going to be a red color pigment, and in both of these you studied the same thing. It is going to be non-diffusible. It's not going to diffuse out because shortly you will do a pigment which will diffuse out. Okay, so this is done with the tribe Klebsiella. What do we move on to next? We now go on and start our story of the tribe Proteae, and I told you Proteae is going to be PPM, means it's of course going to have Proteus, but it's also going to have Providentia and Morganella. Did I just tell you the punch kiss mnemonic in which I told you that all of them, that Proteus wala is urease positive? So Proteus to hai, Morganella is also there. This Providentia is not. So Providentia is not urease positive. Proteus and Morganella is going to be urease positive. But one thing which everyone is positive is the phenyl pyruvic acid testing. Phenyl pyruvic acid testing, if you can learn this just by not being very inquisitive, I will be very happy about it. But if you are one of those who have a lot of curiosity and want to know what is phenyl pyruvic acid, although I feel when it comes to micro, half your curiosity kind of goes away. But still, phenyl pyruvic acid testing means that you are going to form phenyl pyruvic acid from what? Phenylalanine. So how is phenylalanine converted to phenyl pyruvic acid? This means the bacteria have an enzyme, phenylalanine deaminase. Yes, there's basically an enzyme that is present called phenylalanine deaminase, which will convert the phenylalanine to phenyl pyruvic acid. Again, as I said, keep it simple. All of them are going to produce phenyl pyruvic acid. All of them are PPA positive. So remember, PPM is PPA positive. Proteus, Providentia, Morganella. PPM is PPA positive. Proteus and Morganella are also urease positive. Providentia is urease negative. Of course, my primary concern is going to be Proteus. And do you know what is the meaning of the word Proteus? Proteus refers to Greek god. Greek word hai, which means it can take any shape. It is a pleomorphic bacillus. And I have already told you we are studying the gram-negative bacilli. This also doesn't have a capsule, but this has a very important motility. Rather than motility, I try to call it growth, and that is the swarming growth or swarming motility. Please note, this concentric round and round and round thing that you're seeing on a blood agar, that is swarming. So this level of concentric growth cycles, that is referred to as swarming. And let me tell you once again, guys, that this is not just seen with Proteus, it is seen with PVCs. What is PVCs? So first, of course, you have Proteus, but in a while, you will be studying something called Vibrio parahemolyticus. You will be studying something called Vibrio parahemolyticus. Also another Vibrio that is known as alginolyticus. That is exactly the next chapter that you have. So basically not Vibrio cholera, but Vibrio parahemolyticus and alginolyticus. Then I have already taught you Clostridium tetani, and Clostridium matlab spore forming. Is there any Bacillus with a C? Yes, Bacillus C wala matlab Cereus. Bacillus cereus also shows it. And finally, there is one thing that we just now studied, Serratia. So Serratia also shows you swarming, which means I will finally go back and complete my mnemonic. Serratia shows you swarming, surgical site infections, red color, pigment, room temperature. So sounding well? So SSRR for Serratia. Coming back, who all shows you swarming? Proteus, Vibrio parahemolyticus and alginolyticus, Clostridium tetani and Cereus, and Serratia. So now swarming kisme dikhega? All that PVCs to you have done, but you don't want swarming. You say, ma'am, I want to see a plain growth. I don't want to see the round and round thing. How do I stop the swarming? First, use a very firm agar. Imagine if I make your surroundings very tight. I close the doors, the windows, and I put a rope around you, tie you up in a rope. Will you be able to move? No. This means a firm agar, firm for 5 to 6% ka agar kar do. If you have read in your culture media chapter, normal concentration of agar is somewhere between a 2%. I am now making it very, very tight, very firm. How will the bacteria move? So this means swarming will be inhibited. If I add some chemicals, like I add some chloral hydrate, some boric acid, chemicals are always toxic. They will not let anyone move. And thirdly, McConkey agar inhibits swarming. Okay, that is news, guys. What was the, come on, tell me, what was the composition of McConkey agar? It's a pretty pink plant. T, taurocolate. Taurocolate matlab bile salts. Bile salts are damn toxic. So that means all of these features are then going to inhibit swarming. So what are the 3 methods of inhibiting swarming? Either you make a firm, very tight agar, 5%, firm 5, or you use McConkey because McConkey has bile salts which are toxic, or you add some chemicals like boric acid, chloral hydrate, they are also toxic. Now you see that is there any use of this swarming in terms of epidemiological typing? So for example, there are 5-6 patients in the ward who have ended up having Proteus. Now you want to find out that are all these 5 patients in my ward having the same Proteus? Is this something which is like spreading in this ward? Is this one type of Proteus only spreading? Or are they all genuinely having individual Proteus infections? So if you want to know that are you dealing with the same strains of Proteus, or are you dealing with different strains of Proteus? What are you going to do? You'll take this blood agar, you will put one strain over here and one strain over here, right? Both the strains you have kept. Now, this will also start swarming from here. This will also start swarming from here. Right now, you don't know whether they are from the same family or not. One Proteus here, one Proteus here, they start swarming. So now tell me, if you, and 2 scenarios, if you have a meeting fixed with your best friend versus you have a meeting fixed with your enemy, whom are you going to go and hug as soon as you meet? Whom will you be very, very happy to meet? Obviously your best friend. So if you and your best friend will meet, you will hug each other. You will fuse into each other. But if you and your enemy will meet, you will come to each other but say hello and go away. You are not going to hug each other. So simple. Same hai. Best friends hai, their swarming will merge. But if they are different, they will separate. So this means that in same strains, the swarming is going to merge. Whereas if they are different, then you will see a line of demarcation. They will maintain their distance because they are enemies. So yahan pe what happened, as I saw over here, I could appreciate when I zoom in that this was swarming from here and this was also swarming from here. But somewhere when they got close to each other, they decided that nahi, I don't think we are the same people. We have to kind of be a little separate. There is a tiny little separation that you see in between them. Matlab there is a line of demarcation. demarcation. This means they were different strains. Simple. If they are same best friends, their swarming will merge. If they are different enemies, there will be a line of demarcation. Is there any other? So this will help me in knowing that are all the people in the ward having the same Proteus, or is it different? It's for epidemiological typing, and this is known as the Dines phenomenon. So what is this Dines phenomenon? Dines phenomenon means that you are testing for this epidemiological typing. Also, another thing that you have to know is that do not confuse it with something known as a Dines stain. Guys, for what do you do a Dines stain? Dines stain is something which is done for mycoplasma, which we'll study right in the end in the miscellaneous chapter. That is Dines stain for mycoplasma. So tell me, other than this, is there any other use of Proteus that we have? Yes, I'm going to take up the non-motile strains of Proteus. If I take the non-motile strains of Proteus, especially Proteus mirabilis, and I use the OX2, OX19 and OXK, I'm not using it for Proteus. I'm taking this from Proteus, and you know what am I using it for? I'm using it for the Weil-Felix test in Rickettsia. So in Rickettsia, you do a test called the Weil-Felix test, in which you actually pick up what? You take the strains of Proteus, OX2, 19 and OXK. We will study about this test in Rickettsia, so I just wanted to mention it. Finally, what do you do in the treatment? Highly resistant. So you have to definitely known for its resistance. You have to go for antibiotic sensitivity testing. Ampicillin and cephalosporins are usually used in the treatment. So if I can give you a very quick recap, Proteus, did I tell you all these members are PPA? The PPM are Proteus phenyl pyruvic acid testing positive. Have I told you another thing with P, that is it is a Dines phenomena positive? Have I told you that this is going to be an enzyme called US, that is urease positive? Did we study S for? It shows you swarming motility. And now I can tell you that whenever they ask you what is the odor, this tends to give a fishy, dirty odor. So these are the points of Proteus: PPA test positive and Dines phenomena. Then you have the odor, which is very, very fishy. Then you have the Proteus, us for urease positive and S for swarming. I'm just giving you these small mnemonics because I know in the last days you will not be able to study everything. So you can skip through these. Acha, Klebsiella ka name Klebsiella, Proteus ka name Proteus. That is what it's going to help you a lot in. So we were doing which family? Tribe Proteae. Proteae is done. Providentia, you don't have to know. Morganella, you have to know. So out of Proteae, Providentia, Morganella, I just want you to learn M for Morganella, M for Machi. Okay, that is how I have learned it. M for Morganella, M for Machi, because this is associated with food poisoning of uncooked fish. So this is known as the scromboid food poisoning. This is known as the scromboid food poisoning. So simple as that, you have to know Morganella matlab Machi wala food poisoning. Machi wala food poisoning, fish. Okay, so this is also done. There's another tribe that we have which has only one organism, and that is the tribe Erwinia. And what is the organism that it's going to have? It's going to have the Erwinia herbicola. Erwinia herbicola. So please note, this is the one that causes UTI and it is associated with a yellow color pigment. So remember, Erwinia is going to have yellow UTI, and there is nothing else about it that you have to know. So simply the tribe Erwinia